Good evening and welcome to the Scientific Adventures of Beardman. Today we're going to take a look at power, which is the rate at which work is done. In the last lesson we learned about work. We said that if you put a force in a direction on an object and move it a certain distance, the force times the distance is the amount of work that you've done. The power is the rate at which you're doing it, meaning how many joules of work can you do each second. Okay, so our equation will be power equals work divided by time. So our total work divided by the amount of time it took us to do that work will give us how much work was done each second. Okay, now you're probably most familiar with power actually from light bulbs. Okay, because once we take this power and we multiply it out, let me show you. Let's just say we push on something with 20 newtons over 4 meters, 80 joules of work. And then let's say that takes us 2 seconds. Well, 80 joules divided by 2 seconds gives us 40 joules per second. Well, joules per second is once again a common enough unit that we have a special name for it, a derived unit. And that is the watt. Okay, which you're familiar with from light bulbs. That's the most common thing that we talk about being in watts. Okay, if you have a 100-watt light bulb, that means that it's doing 100 joules of work every second. Okay, well that's a little strange. Light bulbs don't push on anything, right? Well, this will start to lead us in the next video into our connection between work and energy. Okay, but the light bulb is essentially giving out 100 or using 100 joules of energy every second. Okay, and that's where that 100 watts comes from. Okay, so it's using that much energy. For now, and the things you'll be working on, we're looking at how much work is being done each second. Very specifically, a force pushing over a distance. Okay, so as we take a look at that, when you're working out, okay, you're lifting weights, okay, if you take the weight of the dumbbell, okay, or the bar that you're lifting, okay, let's just say it's 400 pounds, you know, what I lift on a daily basis, you know, just so that 400 pounds, about 200 kilograms, 2,000 newtons of force approximately. So 2,000 newtons of force I have to counteract. So I have to be pushing with 2,000 newtons of force. Okay, I lifted about a meter. Okay, my length of my arms is about a meter. So 2,000 newtons times 1 meter. I've done 2,000 joules of work. Well, if I can lift that in half a second, okay, because you know I can lift in easily. Yeah. Okay, but so I lifted in half a second. We have 2,000 joules divided by half a second. We get 4,000 watts. Okay, so that's my power for lifting something. If I really was that strong. Anyways, I lifted with my mind. Okay. Anyways, so that's power. Power is the rate at which work is done. How many joules of work are being done each second. We'll see you next time on the Scientific Adventures of Beardman.